Yes, the London forces. How about dipole-dipole? Yeah, dipole-dipole, that's only when you have the polar molecules. So that's not going to exist between chlorine molecules. What about hydrocarbons? There's no hydrogens. So based on this information, would you expect chlorine to be soluble in water?
No.
No. Okay, so although chlorine is not expected to be soluble, we can get some of it to dissolve in water. Okay, so that's what you did in that lab last semester. You looked at chlorine in water. You got some chlorine to dissolve in water. So here's the chlorine I showed here. Here's the chlorine. So here's the chlorine dissolved in water. Now, if you add hexane to this chlorine water solution and shake it up, the chlorine is more soluble in hexane than in water. Now, why is chlorine more soluble in hexane than water? Because hexane is non-polar. Okay, so chlorine is non-polar, hexane is non-polar. We expect chlorine to be more soluble in hexane than water. So what happens is that when you shake up this hexane water chlorine mixture, the chlorine is going to move, or it's extracted or leached from the water layer into the hexane layer. Okay, so this is an example of a liquid-liquid extraction. Now, in a liquid-liquid extraction, the two solvents, the water and the hexane, have to be insoluble or immiscible in each other. In other words, you can't do a liquid-liquid extraction. And then in lab 1, you did another liquid-liquid extraction. So you took a mixture, actually this is for the 2 o'clock lab. You took a mixture of the banana ester, the isoamyl alcohol, and the acetic acid. You added water to that mixture. The blank and the blank are more soluble than the blank and the blank. So the water, alcohol, and acid are extracted into the water. So what goes in those blanks? Is it going to be the ester and alcohol are more soluble in acid than in the water, so the alcohol and acid are extracted more. Or is it the alcohol and acid are more soluble in the ester than in the water, so the alcohol and acid are extracted more? Or is it the alcohol and acid are more soluble in the water than in the ester, so that the acid and alcohol are extracted into the water? Does everyone have an answer? Who says it's A? Who says it's B? Who says it's C? Yes, you're right. It's C. So note that in that extraction, the unreacted alcohol and acid mixed with the ester is extracted into the water. That's because the alcohol and acid are more soluble in the water. Okay. Now today in lab, you're going to be doing a solid liquid extraction. So you're going to take those coffee beans. Coffee contains quite a few compounds. I think it's something like 100 or 150 compounds. Coffee. One compound, perhaps the most important one, is the caffeine. So here's question A. What substance is used to remove or extract caffeine and the other substances from coffee beans to make a cup of coffee? So what substance do you use to extract the caffeine and those other substances? Yeah, so when you make a cup of coffee, I'm not sure how you make it. Maybe you just use a filter, or you got your coffee machine, or you got your French press, or you got your whatever it is. So yeah, use water. Now, what you'll do with the lab is you're going to look at the factors involved in how to extract all those substances from coffee. So, like Elias says, one factor is temperature. So, will more of these substances be extracted if you use hot water or cold water? So, what do you think? Probably hot water. So, we'll test that today in lab. What other factors do you think are involved?
Surface area.
Yeah, the surface area. So, if you're making coffee, are you going to extract it from these big beans, or are you going to grind the beans first? Yeah, so what's the reason for grinding those beans? Yeah, you increase the surface area. So that's another thing you do. What's another way to extract these substances from coffee? What's another factor? Okay, so there's temperature and surface area, and it could be pressure. Although pressure, when we look at pressure, we look at the pressure of gases. Okay, so I'm not quite sure if there's any gas substances in coffee. All of this is aroma. Anyway, anything else? Wait. Yeah, so the amount of coffee beans that you use is important. What else? Let's see, there's temperature. There's temperature and surface area. There's pressure. There's the amount
The time.
of coffee that you use. Yeah, time. So note that
Concentration.
the amount of time the solid coffee is immersed in the water is going to determine, well, may determine the amount of caffeine or those other substances extracted from coffee. So these are a few factors. Okay, so you're going to figure out what factors are important in extracting caffeine and coffee substances from the coffee beans. Now, what we'll also discuss in lab is how are we going to determine how much is extracted from the coffee. Okay, so we'll figure that out too in lab. Okay, part B. Okay, we discussed what factors determine how much stuff is extracted from coffee. Part C now, what substance can be used to remove or extract the caffeine only from coffee beans to make decaffeinated coffee? So can you use just one substance to extract caffeine, leaving all the other substances behind? I'll say still in the beans. And then what you can do then is then you can make your coffee without the caffeine. So is it possible to add one substance to make decaffeinated coffee? Yes, that's actually one way. If you go online in lab and look it up, yes. So one way, so Luke's is saying one way to decaffeinate coffee is to make a regular cup of coffee. Once you have your liquid coffee solution, then you're going to add a substance to that solution to extract the caffeine only. And then there you have to figure out a way to get the rest of the coffee substances in solution back into the solid coffee.
You just let the beans absorb.
Yes, that's one way. So there's at least one or two other ways to do it. So you look up these different ways to extract caffeine from the coffee. So that'd be another example, but solid liquid extraction. Then for part D, what factors are considered? So we'll look at these factors in lab 2. Okay, so in part A in lab 2, you're going to figure out how to make a good cup of coffee, and then you'll also figure out how to decaffeinate it. Okay, let's go on the next slide. You may have done this before. Boiling water to make beans or spaghetti. Why do you add salt to the water? Okay, so you add salt to the water to make this water salty so to improve the taste. Or you add salt to the water to make the water boil faster. Or you add salt to the water to cook the spaghetti or beans faster? So which one is it, A, B, or C? Okay, so let's define these terms. Okay, so you have, let's say you have two pots. It contains the same amount of water. And you're heating these up on your stove. Okay, so here's your hot plate. Okay, so here you have the same amount of water. So this is water only. And this is water plus salt. So for part B, makes the water boil faster. So again, you have the same amount of water, the same amount of liquid in each pot. So make it boil faster means that you start, the temperature, the initial temperature is the same. You apply the same amount of heat to start heating up the water, saying that this one will start boiling faster than that one. That's for part B. Then for part C, it cooks the pasta and beans faster. So once these two liquids are boiling, you put your pasta or your spaghetti, the same amount in this one as in this one, saying that this one should cook fast, cook the beans or spaghetti fast. Okay, so which one is it, A, B, or C? Yeah.
I'll do it. Yeah, sure, I'll do it.